Thanks everyone for coming today to my presentation about scalable, high availability Asterisk using Docker and CoreOS. My name's Doug Smith. I'm coming out of Vermont. This is a photo at peak foliage right now, just before I left for Astricon. I am super interested in systems and development, which makes me very interested in DevOps. I develop Asterisk solutions every day as part of my job for 800 Response. One of our top products right now is Call Finder. It's a speech analytics tool that I think can add a lot of value to the call center. Historically, one of our top offerings is mnemonic and vanity toll-free numbers. So we have a really strong telephony background, and luckily for me, we implement a lot of open source software. So let's get into it and take a look at a 10,000-foot view. First of all, you can find the whole presentation available online at astricon.dougbtv.com. It also includes links to a do-it-yourself workshop. It's got a bunch of code examples, Docker files for everything that I'm going to talk about. And additionally, this entire presentation is in Markdown, so you can easily go and copy code samples from it. Heck, you can even fork it if you want. If you've got any questions, hit me up on Twitter at DougBTV, also on GitHub for the same. And for the sake of time management, if you could save your questions to the end, that would be awesome, because I've got to cover a lot of ground. First thing we're going to do is do an intro of the technologies. There's kind of a Cambrian explosion of technologies in this realm. So you're going to have a lot of choices, and we're going to go over a lot of those. We're going to talk about how to get CoreOS up and running. We're going to go through kind of a sample system architecture, and then we're going to look at some software that I wrote called Cometelio etcd Dispatcher, which adds some service discovery for Asterisk under Cometelio. This is also going to give us some continuous deployment opportunities, so we'll briefly go over those too. Some of the considerations that I have are, at the top of the list, high availability. And when I say high availability, I mean that when there's a failure, I don't want calls to drop. And when I can't do that, I'm going to mitigate it. When calls are dropped on my platform, that's a tangible loss of revenue, and that's just a non-starter for me. So that's at the top of my list. Next up, I want to make it scalable, because if I've got a good problem, like I need to support more traffic on my platform, I want to make it easy for me to go in and add more capacity to my system. Once we put those together, there is some complexity, so I want to make sure that I have a good visibility of this platform, and especially I want to have a good visibility of the whole SIP stack and all of that VoIP traffic that's running over my network. And last of all, I want to make sure all of that is manageable, because there's a lot of moving parts, so I want to make sure that I have some repeatability and everything is just manageable enough. So let's get into intro to the technologies. And first up is Docker. And hopefully you guys got a chance to see Leif and Darren's talk yesterday, because they went really deep into it. But in short, if you didn't have a chance to do that, the kind of 2-second intro is, it gives us a way to package together our applications, processes, and their dependencies so that we can have repeatable units that we can spin up dynamically across our cluster. The 2-second business case is, say your company provides ASCII art cows to your customers. You'd make a Docker file that says, this starts from Fedora, I'm the maintainer, use yum to install a cowsay program, and then you could spin up instances of that container and make ASCII art cows to deliver to your customers. There is another choice. There's probably a number of other choices, but one that you might want to look at is Rocket. It's another system like Docker that sits on top of Linux containers. Rocket is created by the makers of CoreOS, and CoreOS is a ultralight operating system that you're going to run your containers on top of. I really like it because it's bootstrapped with a bunch of tools that make this really easy for us. And one thing that was kind of a downer to me was, oh no, I'm going to have to use a totally different Linux distribution than I'm used to. I'm a Red Hat guy from way back, and I use CentOS, and I use Fedora on my workstation, and I'm going, oh man, another Linux distro. This is a bummer. But the thing is, if you're used to systemd, using CoreOS is going to be trivial for you, and then everything that you're really concerned about from like a development standpoint, from the applications that you're used to using, like Cometelio and Asterisk, you're going to run them in containers, and they're going to be in a context of the distribution that you're used to using. So I really don't feel like there's actually a lot of pain there, but sometimes that sounds a little bit difficult. Another choice that you might consider too is Project Atomic. It's another distribution that is used for running containers on, and it comes from the Fedora guys. But we really like some of the tools that are offered with CoreOS, and one of those is etcd. And etcd is a discovery service, and the basic use of a discovery service is you're going to have one service come up and it's going to say, hi, I live over here, and then another service is going to come up and it's going to say, hey, where does that service live? And it's going to ask the discovery service and find that out. etcd is really simple to use. You use it over a REST API, so any modern programming language, it's going to be real easy to do it. You could use curl to go ahead and set and get keys from it. Based on top of etcd, we also have Fleet, and Fleet is a scheduler. And what Fleet allows us to do is spin up processes dynamically across our cluster. So we could say, hey Fleet, I want 3 instances of Asterisk, and it's going to pick 3 appropriate machines and spin up 3 instances. And it's going to maintain those. So if one of those dies, it's going to spin up an extra one for you. So it's going to make sure that you've still got that capacity. Fleet's easy to use. If you're using system control, systemctl, it's basically just like that. It just happens to run across your cluster. It's a pretty low-level tool, and there are higher-level tools in this realm. A couple you might want to look at are Mesos by Apache and also Kubernetes. Kubernetes is a pretty advanced scheduler, and it can implement quotas, so you can do some dynamic scaling with it. So at a super huge scale, it might be the appropriate tool for you. We're going to use Cometelio. In this context, we're going to use Cometelio as a load balancer, and we're going to use it alongside of KeepAliveD that we're going to use to provide a virtual IP to provide high availability failover between Cometelio instances. However, I will say it with the caveat that if you're using public cloud, it might not be the right choice for you. You might want to use their software-defined networking because KeepAliveD is a VRRP in the back end. So that's multicast traffic. That's not exactly ideal for public cloud. We're going to also use it with Cometelio etcd dispatcher, some software I wrote for service discovery, and we'll get into that a little bit. And since this is our load balancer, it gives us continuous deployment opportunities. We use Homer for... Sorry about that. We'll use Homer for visibility of our VoIP traffic. I won't go into it deep here, but when you check out the do-it-yourself workshop, you'll see that there's a bunch of Docker files for it and everything you need to get it spun up. There's also some supporting tools that you're going to want to use, and one of those is Flannel. It comes packaged with CoreOS, and it provides some overlay networking to give you a kind of common subnet. Another choice in that realm is also Calico, which is for a similar purpose. You're going to want to use configuration management. I really like Ansible, but anything else in that realm is going to fit the bill. Salt, Puppet, Terraform, name it. It'll be good to go. Also, consider your application logging. We'll have the visibility of the SIP stack with Homer, but we really want to log what our applications are doing, and you might want to consider the ELK stack, Elasticsearch, Logstash, and Kibana. Really great set of tools, but one way or another, make sure you centralize your logs. And of course, yes, we will use Asterisk too. In fact, all of this is set together so we can run our Asterisk on top of this platform. So let's talk about getting CoreOS and Fleet up and running. One of the first things you're going to run into with CoreOS is using a cloud init script. You might have run into this before if you're using OpenStack or AWS or DigitalOcean. You've probably seen this. If you haven't, it's not a big deal. It's just a YAML file, and we're going to set some SSH keys, some basic networking properties, and we're also going to spin up some services such as etcd, which I mentioned. And outside of your networking specific considerations, this is probably going to be one of the most difficult parts. And it's not because etcd is difficult to use, it's because you're going to spin up a cluster, you're going to tear it down, you're going to spin it up, and you're going to see every possible failure mode for it. But once it's up and running, I've found it to be really rock solid, and it's bone simple to use. If you use AskDB, you already know how to use a key value stored database, and essentially you're just going to set keys and get them. No big deal. With etcd in place, we can start to use Fleet. And in order to use Fleet and get those instances spinning up dynamically across our cluster, we're going to create Fleet units. And Fleet units are just like systemd units with a little bit of metadata attached. If you're not familiar with systemd, I really encourage you to go and get used to your new overlord. There's some controversy regarding systemd, and a lot of it is merited. However, as an init system, it's actually fairly powerful, and I find it really easy to use. And for my money, it's a lot easier than creating System 5 style init scripts. We also can do some pretty neat stuff with the metadata inside of our Fleet units. And one of those things is we can set metadata at the cloud init level, and then we can set dependencies and conflicts between the two. So the textbook example would be you've got a database service and you've got a backup service. And our textbook says you don't want to run those on the same server. So you're going to say those two conflict. And in this situation, we would say Cometelio, our load balancer, conflicts with our Asterisk service. Because if those are on the same machine and that machine goes down, we're going to lose two classes of service at once. So we're going to set some of these dependencies and conflicts using these Fleet units. Once you've got those set, then you can start spinning up instances. And this is really where some of the scalability comes into play. It's just as easy to start 2 instances of Asterisk as it is to start 200 instances of Asterisk using Fleet. It makes it quite easy. Fleet also has some cool features, like it can pick up the logs across the cluster. So for example, if you want the logs for the 15th instance of Asterisk, you can get that from any machine using Fleet. And you can also SSH to any box in the cluster using Fleet. And good consideration by the CoreOS guys is it uses SSH agent forwarding to accomplish that. So you tell your SSH client, forward my credentials, and then you'll have access to the boxes that you're permitted. So that way, if a machine was compromised, the attacker wouldn't necessarily have the credentials to access the entire cluster. A couple tips that I have regarding CoreOS is, firstly, when in doubt, go ahead and check your etcd logs. A lot of tools rely on etcd, and you want to make sure it's up and running. Everything hinges off it, but luckily it's distributed, and there's always a way to get the health of that etcd cluster back in action. Another thing is to think n+1 with everything that you're doing. Spin yourself up an extra box in the cluster for utility, and then make sure that there's an extra machine for each class of service. So if you're going to say, I want 3 instances of Asterisk, make sure you spin up 4 machines. That way when one of the machines dies, Fleet has an extra space to spin up an extra Asterisk instance. So let's take a look at a sample system architecture. And this is the way that in the do-it-yourself workshop that we've got it set up. Our really simple business case is we want to have a customer pick up a phone, dial, and then they're going to hear our Asterisk playback TT monkeys. And that's what our customers want, is just to hear screaming monkeys, which is a great, easy business case. We're also going to have kind of a Kumbaya/Disney World situation where our ITSP is going to live on the same subnet as our Asterisk machines to simplify the networking. In reality, your networking is probably going to be a lot more complex, and it's probably going to be a really layered approach to this simple situation I show here. One more thing, this kind of comes from a tandem switching perspective, so it's really kind of based on SIP trunking. So if you have a bunch of devices connected to your network, which is likely for a number of people, you're going to have another couple considerations. So keep that in mind as you go through. This is what our stack looks like in general. We start with our host, and on that host we run CoreOS, which comes packaged with etcd. And then we're going to run Docker on that host, and then we're going to run our containers in Docker. And without getting into the detail of all of these pieces here, is these are the different processes that we're going to run. They're going to run in Docker, and some of them are going to be packaged with sidekicks that are used for service discovery. I'll talk about that too in a little bit. Here's the general gist of how our networking is going to work in this simple business case. Is we're going to have our ITSP/gateway, and it's going to create SIP messages across to a virtual IP that's provided by keepAliveD between 2 instances of Cometelio. And then on the other side, we'll have n number of Asterisk machines, and they'll also speak to that virtual IP, so that if there's a failover, the secondary will pick up that virtual IP. In terms of high availability, a few considerations here. Number one is, in the do-it-yourself workshop, I don't really go into a replicated dialog state with Cometelio, and it's possible, and you should definitely do it in order to keep your calls up and healthy. If there's a failover and there isn't a replicated dialog state, you're going to leave calls in an intermediate state. Probably you're going to have pretty good uptime still, but you're going to have some wigginess and leaving calls in an even more intermediate state if you don't solve that. However, the reasoning is, in order to do that, you're also going to want to have a redundant database technology in order to go with that, which is kind of out of scope. It's not impossible. In fact, it's not hard, but it's a lot of work. And lastly, we have RTP flowing directly to our Asterisk hosts. We're not using an RTP proxy in this particular situation. And also another high availability note is you're also going to probably want to have a replicated state machine for your Asterisk boxes so that you've got one-to-one hardware redundancy. Your cloud provider probably should provide it, but maybe you figure out how to do it with OpenStack. Maybe you're using VMware. There's another way, because if you don't have that and an Asterisk box fails, calls are going to drop on that machine. And the thing that's in our favor right now is we're using a load balancer. So if we have 10 Asterisk machines and we lose one, that way at least we're only losing 10% of our traffic. So at least we can get we can mitigate the number of calls that are going to drop on a failure. So the way that we're going to put this together is we're going to use Asterisk and Cometelio, and we're going to pack it together with Discovery Service. And to kind of keep these disparate components together, I wrote some software that I call Cometelio etcd dispatcher. It's just a very verbose name. It's not one of those clever, cool names like named after a vegetable or something. But the gist of it is it's written in Node.js, and it watches particular etcd keys, and then it reacts on them. So I thought that Node.js was appropriate because it's event-driven. It's open source. It's available on GitHub. It's also available on Node Package Manager. Give it a look. I think it has some cool considerations. However, it's not complicated. It's probably something that you could also write for yourself in an afternoon in Bash. It's not a big deal, but there are certain things I wanted it to do that I just put a little bit more time into it, especially in terms of continuous deployment. I'll talk about that a bit in a minute. It essentially runs in two modes. One mode is an announcer, so the Asterisk can announce when it arrives, and then it runs in another mode where it's a dispatcher that sits alongside Cometelio to detect when Asterisk has come up. So if we've got an etcd cluster and we've got an Asterisk instance up, that Asterisk instance will come up with the Cometelio etcd dispatcher, and it'll say, hello, I'm Asterisk. I'm over here at this IP address, and I'd like to come into rotation at the load balancer at, say, 5%. And then sitting alongside Cometelio, we have the dispatcher version of this application saying, OK, gotcha. I'm going to put you into rotation at 5%. It does that using the Cometelio's dispatcher. So it updates the Cometelio dispatcher list, and then it uses Cometelio control KMCTL in order to reload Cometelio config. And so that's the general gist of what it would look like. It knows the IPs, it knows the weights, and it gets that all set for you. And it can run in multiple places so that those dispatcher lists are always the same across redundant instances. We put these together by using a pattern that's called a sidekick pattern, and that is one process that depends on another using fleet units. So you kind of have your hero process and its sidekick. So if you had a process called Frodo, you could also have its sidekick Samwise, and you could use those to simply walk into Mordor. And in our case, our heroes are Cometelio and Asterisk. So the etcd dispatcher sits in both modes as a sidekick that depends on that hero process. If one of those hero processes dies, then the sidekick dies alongside it. We get a couple different ways to take an Asterisk machine out of rotation using this. One of which is using the Cometelio etcd dispatcher. We send a heartbeat message over etcd, and the dispatcher looks for that heartbeat to see that it's alive. So if Asterisk dies, sidekick dies, it stops the heartbeat, it'll take it out of rotation. Redundantly, we also do that on the VoIP side, and we use a probing mode in Cometelio dispatcher. And basically what that does is it sends a options message to Asterisk, and we set certain classes of responses that we want to hear back to say, okay, it's okay to route calls here. So the different ways we would take an Asterisk box out of rotation is, number one, Asterisk fails and it doesn't respond to that options method. That way we take it out of service, and we'll route advance to another Asterisk machine in the cluster. We can also say an Asterisk core shut down gracefully and drain calls off of those systems. So when you're going to do a rollout, that's going to be important to get people off of your old version of software, and but keep the calls that are up and running. The web guys have it really easy because they have really short requests, but you could have somebody on the phone for an hour and a half, 2 hours or more. We don't have that luxury. Lastly, you can just stop the announcer. That would be another way to drain calls off of the system. To get it back in rotation, Not a big deal, just start the announcer again. Since it depends on Asterisk, you're going to need to have both of those running for it to come back in service. But what if Cometelio dies? Well, we use the same sidekick pattern, and we have keepalive running as a sidekick to Cometelio. So if Cometelio dies, keepalive dies, that's going to cause the floating IP, the VIP, to fail over to the secondary Cometelio instance. So since we've got this up and running as a load balancer, or Cometelio running as a load balancer, and we've got a way to dynamically spin up instances, we have some great opportunities for continuous deployment. So here's what a platform might look like in its nominal state with your current release of software. And you'd have traffic coming into Cometelio, and it's being load balanced equally across these 4 machines. And you decide, OK, I want to roll out some new software. Well, what are some safe ways to accomplish that? One of those ways would be to use a canary release. And the Cometelio etcd dispatcher supports a canary release paradigm. And the idea behind a canary release is it's like a canary in the coal mine, where they would put an animal in a coal mine to see if noxious gases affected it before the humans. So we would put our software out there as a canary at a low percentage of load balancing. And then we could take a look at that software and make sure that it's good to go. So in this case, we've got our canary release at just 4%. And if there's a catastrophic failure, we're just going to lose 4% of our traffic, which is great in comparison to losing a lot more if you flash cut everything in there. So that's one way. Another way that you might consider is using a blue-green deployment. And in this way, we would create 2 instances of our platform. One of those instances, our current release, our green deployment, up and running. We set up everything again in a redundant instance of our platform in the blue release. And then we could flash cut over to it. We could let calls drain off of the green platform while new calls go to our new release of the software. That's another way you might want to consider it. And since we can dynamically spin up machines with Asterisk on them, it's not such a big deal to do something like this anymore. And the safety mechanism here is once you're switched over to your new release, if there's a failure, you keep your green environment up for a while so that you can switch calls back to the green release if you need to. The general catch-22 for these kind of continuous deployments is any type of shared storage, shared data structures, your database. You're going to have to consider that carefully during your releases, because that could be a catch-22 for you. So thank you guys. Really appreciate you coming. This is technology I'm pretty psyched about, and I'm psyched to see a bunch of people that wanted to hear about it. So make sure to go online and check it out at astricon.dougbtv.com, and you'll be able to see all the code samples and get this presentation, et cetera. So thank you guys a ton. I'll take any questions.
Does Docker have any kind of geographic kind of containerization? So it's like, you could put your whole cluster for like the whole country together as one unit, or would you have to build a separate Docker, like with the fleet and Docker grouping for like East Coast, West Coast, Central?
And what I would do for that is, one, I would use DNS SRV if the other components in your network support it, but then I probably would use Ansible to spin up, say, 3 clusters.
Okay.
That's what I would probably do.
Any particular reason you'd Node.js over anything else when you for that etcd? Oh, sorry.
Essentially, I liked it because of the event-driven nature of it, to say I'm putting a watch on a key and I'm going to act on this event. But I don't know that there's necessarily a right or wrong choice for that one. Probably, yeah, you could even use a bash script and it'd be good to go.
Is there any need for a turn server in the architecture? Do you have any mechanism where you can containerize a turn server?
Containerize what? I'm sorry.
Turn server.
Oh, yeah, absolutely. You could containerize a turn server. And yeah, I'd absolutely encourage you, if you go through the DIY workshop, to spin it up in a stock state and then start adding on and containerizing the services that are particular to your business case. Turn server is a great example of that. So there's no reason why you couldn't containerize that and run it in the same way and scale it the same way too.
Why resort when you have the full CoreOS stack? Why? What role does the Ansible serve, the configuration manager?
And that's an awesome question. And the general gist for me is that I want to automate all of the steps for it. So for example, I spin up CoreOS cluster, and then I want to install my fleet units, for example. I Ansibleize that so that I've got version control over all of those different files for the fleet units, and then I'll load them up all onto the machine. And then I've also created a few different playbooks, and again, they're on GitHub, that will do things like fix some common etcd failure modes and other things of this sort, so that I've got just a consistent way to do that stuff over and over again. Sure.
Docker machine in place of Ansible or Puppet or anything else?
And I have not, but yeah, that's definitely a way to go for sure. That's yeah, that's a very good call. And also Docker Compose. Docker Compose is awesome. In my GitHub, you'll find that I made those fleet units manually, so they'll have like a literal Docker run command in there with all the parameters that you would want. And also I use Ansible to parameterize some of those fleet units as well. But you might want to look at using Docker Compose in place of those literal Docker run commands. I think that's probably a lot cleaner way to do it. Anyone else? All right, guys, thank you a ton. I appreciate it.